Hi there. In this video, we'll see how we can interface relays with microcontroller. What is the need of interfacing relay with microcontroller? What are the different ways of interfacing it and everything with respect to the switching about relays. Let's begin. Now, before we actually go into the presentation and all the details about it, let's try to understand what exactly is the scenario when you want to control some real world devices with microcontroller. We might have seen that you can connect a microcontroller directly with an LED. So you can just have an LED like that, write down a program for it, make it high and make it low, and that LED will turn on and off. But in real world, in actual world, we don't have just LEDs to power on, but we have fans, we have lights, and we have number of different appliances which we might want to turn on and turn it off. The problem statement is the logic output, the programmable output of any microcontroller, or particularly this 8-bit controller like Atmega, is 5 volt or 0 volt. If we go into the advanced controllers like any ARM based series controller, then it is usually 3.3 volt or 0 volt. So 8051, Peak, AVR, and number of different 8-bit controllers whose logic level is 5 volt. For them it is 5 volt and 0 volt, and for rest of them it is 3.3 volt or 0 volt. So logic 1 and logic 0. Now the issue is at this level of voltages. Moreover, there is one more problem. Not only that it just outputs 5 volt or 3.3 volt, it is also limited in current, how much current it can source from that pin. So it doesn't mean that you can just connect any load over here and allow it to pass 1 ampere of current. That's also not possible. Every microcontroller pin is internally limited to source a particular amount of current, and although it differs from controller to controller, as a general rule of thumb, you can consider it to be not more than 20 mA. Usually, a few microcontrollers like PIC allow up to 40 milliampere of current. Some ARM series controller also allow up to 15 to 25 milliampere of current. So 20 is a standard value one can consider when designing the system for their particular application. Now at this current level, there are only two devices that you can directly connect to the controller pin, and those two devices are LED and buzzer. For anything else, what you need to do is you need to use some different switching circuits. There are DC loads and there are AC loads. Depending upon what you want to do, your load voltages may differ. The discussion that we are going to have today will cover both how to interface DC load as well as how to interface AC load. Now let's try to understand something here. Let's try to understand the DC load first. So when we are trying to interface a high current or a very high power DC device, for example, let me take a DC lamp. Okay, let's consider a DC lamp is there which works on 12 volts. So how do we use this, or how do we use microcontroller to turn this on and off? Whenever you want to use any such high current appliance to be turned on and off through microcontroller, what you do is you use transistorized switching. Transistorized switching means what? We can use transistor, sorry for my spelling, transistorized switching. So when you just have to power on a DC load, then you use a transistor to turn it on and off. And when you want, let's say you have an AC appliance or AC lamp or AC light, then simply transistor is not sufficient. In that case, what we do is we make use of a separate component called as relay. So this session is more about understanding all the different type of output devices that we may want to interface with microcontroller. Let's first try to understand what is transistor edge switching, and then we'll try to understand what is relay switching. And then I will just quickly let you go through the presentation. So when you want to switch on and off transistorized, when you have to switch on and off DC devices or DC appliances, what we do is we make use of a transistor. If you are not aware of it, then you must have been knowing that there are two types of transistors which are available. One is called as NPN transistor. Transistor is a three-terminal electronic component. Okay, so one is called as NPN transistor. This is the symbol for NPN transistor, and the another one is called as PNP transistor. It's called as PNP, and this is the symbol of PNP transistor. I will not go into the theory of transistor because there will be multiple places from where you can study it. I'll just tell you what are the different pin or what are the terminals called as. So this terminal of NPN transistor is called as collector, this is called as base, and this is called as emitter. For the sake of current discussion, I will not use PNP transistors, I will simply use NPN transistors. A transistor can be used for two applications in electronic circuit. First is amplification and the second one is switching. By modifying the amplification or amplifier itself, some more circuit like attenuator and oscillator can be created. But we are not interested into analog electronics for now. So we just want to understand what is the application, what is the use of transistor as a switching device. So I'll use NPN transistor to create a switching device with microcontroller where you can power on and power off high power DC devices. Let's see how we can create that circuit. So let's take a simple NPN transistor first. Connect the base with a resistor. This is your DC load. One point of your DC load should go to the respective voltage on which it is operating. So in that case, it was 12 volt lamp, so it is 12 volt for example. The second point of the DC load should go to collector, and emitter of the transistor should go to ground, and the base with a current limiting resistor should go to microcontroller pin. You might be using Atmega or AVR or PIC or 8051 or STM32 or anything. It doesn't matter which controller you are on, LPC or any LPC series controller or any XYZ circuit which gives digital output. So this goes to the microcontroller pin, and the value of a resistor should be chosen such that the current flowing should not be more than 10 milliampere. So usually what we do is we prefer using 330 ohm resistor. So if you have such a configuration created, what happens is whenever through your program you give logic 1 to this point, it means whenever you make it logic 1 or 5 volt, then the base to collector and the base to emitter, both the junctions are forward biased, and a large collector current flows from 12 volt load through the 12 volt supply through the load towards ground. Whenever you make this particular pin go 0 or 0 volt or ground, what happens is the base to emitter and the base to collector, this is the emitter terminal, this is the collector terminal, and this is base. So base to collector and base to emitter, both the junctions are reverse biased, and this switch is broken. Thereby we come into a switch off position. So you give 0 to it, your load is turned off. You give 1 to it, the load is turned on. Now, depending upon which load you have, your load will decide how much amount of current you are going to consume. And your current amount will decide which type of transistor you will be using. In market, you will get transistor which allow current to pass from 10 milliampere up to 10 ampere up to 30, 40, 50 ampere and so on. So depending upon the type of load that you are having, you should be choosing your transistor. Any kind of DC load like motor, buzzer, bulb or anything such can be switched on using this circuitry. But when it comes to connecting an AC device, when it comes to connecting an AC appliance, this circuit is absolutely not possible. So let me just title it transistorized switching circuit or transistorized DC switch. Okay, transistorized DC switch. Fine. Now, what to do when we have to turn on an AC load? Now, what is the characteristic of AC load? AC load will work on the AC supply voltage. So, what to do when we have AC loads to turn on and off? Depending upon where you are in the world, you might have 110 volt AC or 220 or 230 volt AC with a frequency of 50 hertz or 60 hertz. In India, we have the domestic supply of 230 volt 50 hertz single phase AC supply. This discussion, however, regardless of what type of supply you have, this discussion that we are going to do is equally applicable to all type of AC appliances and AC supplies. Now, when you have AC device or when you have AC appliance to switch on, for example, let's take a fan or let's take a lamp. In that case, what we do is we make use of something called as relay. Now, what is relay? Relay is an electromechanical switch. So, if you look into the construction of relay, then you will see the relay looks something like this, which has got some terminals, and primarily it is used to control a circuit by low power signal. But the important thing here with respect to relay is there is no direct electrical contact of microcontroller and the switching side. So let's see how the relay is. So this is the usual terminal connections of relay. I think if you were more comfortable, I'll stick to the whiteboard. So a relay usually consists of 5 terminals. 2 of them are called as L1 and L2. There is basically an electromagnetic coil which is between L1 and L2 terminal. Then there is a terminal called as NO that is normally open. Then there is a terminal called as common. And then there is a terminal called as NC that is normally closed. The internal construction of relay is such that the common terminal is movable and rest all the terminals are stationary. And since the common terminal is movable, what happens is it is with a spring tension connected to NC. At rest position, the common is connected to NC all the time. So when you check connectivity using a multimeter between common and NC, you will find a beep because those two terminals are always connected to each other. You can see in this diagram here. So the construction is like this. There will always be a beep between common and the NC. So this is the common when you look at the sugar cube relay from the downside, and this is NC. They are always connected to each other. Now what happens is, if using an external signal or if using an external voltage, you give supply to the L1 and L2. For example, let's say plus 12 volt and ground. So if you give the 12 volt and ground to the L1 L2 terminal, what happens is, because it is an electromagnetic coil, it gets magnetized. And because of the magnetism, what happens? This coil acts as a magnet. And then because of this magnetism, this common terminal which was residing previously on NC will now, due to this magnetism, shift towards NO, and it gets connected to NO. It will get connected and stay connected to NO as long as the 12 volt is connected across L1, L2. There is no limit, there is no polarity where to connect L1 and where to connect L2 because it's just a coil. Whenever you remove the coil voltage, what is supposed to happen? The coil is supposed to drop its magnetism and the common terminal will again go back to NC because it is connected with a spring tension. So this is the internal construction of a relay. Now how one should be using it when using in a switching circuit? It is very simple. If this is your switching circuit, AC supply and your load, then how we connect a switch? We connect a switch like this, right? So when you press that switch, the load is on, otherwise the load is off. The same thing will happen here. Only condition is you will use this one terminal as common and the other terminal as NO terminal. So whenever you power on the relay coil, the common will shift to NO, load will turn off, and whenever you remove the voltage, the common will shift back from NO to NC and the load will turn off. If you want, you can also connect multiple loads, one to NO and another one to NC in order to turn on and turn off the load. So this is the concept of how we can connect or how to use a relay for switching the device. Also remember, it is not important or it is not mandatory that your supply should be AC, because there is no contact between these DC voltages and the switching over here. You can use it to switch on AC load, you can use it to switch on DC load as well. It's completely up to you. Usually it is used to switch on and off AC loads. Now the question is, if the relay coil is 12 volt, and it is, not even if, but it is 12 volt coil, and microcontroller cannot still give 12 volt supply, or it cannot also sync the current going from 12 volt supply, then how do we use microcontroller to turn on the relay? So this is the question, how can we use microcontroller to turn on the relay? Think about it. In next video, we'll continue the discussion and see how we can use or how we can create a switching circuit for relay using microcontroller. Thank you for watching this video.